Hi, this is Miss Erig, and I'm going to go over some questions relating to the Integrated Algebra Regents exam. Again, this is the Integrated Algebra Regents exam. The topic we're going to talk about today is relative error. So far in the past 4 Regents exams, there have been 3 Part 2 or 3 questions that deal with this. So we want to make sure that we understand how to do relative error. It's very easy once we get it down. Basically, relative error is the measured minus actual and the absolute value of that number, because we always want it to be positive, divided by the actual. Okay? MA over A, Ma over A. So let's look at question number 38, and this is taken from the August 2014 exam. This is a 4-pointer. The actual side of a square tile is 4 inches. So as soon as I hear a shape, I'm going to draw a picture. The manufacturer allows a relative error of 0.025. So we know this is the actual. And we know our error can be 0.025. Now 2 machines are used to cut the tiles. Machine A produces, this is our actual, we know that machine A produces a square tile with a length of 3.97. Machine B produces a square with a length of 4.12 inches. Determine which machine produces a tile whose area falls within the allowed relative error. So as I mentioned before, we want the absolute value of our measured, this is for machine A, minus our actual, divided by our actual. And remember, our actual is 4. And then we're going to do machine B. Actually, I want you to be able to see it. Maybe I should do machine B over here. And again, it's going to be our measure minus our actual divided by our actual. So let's type this in the calculator. So we know that we're going to do, I'm going to come over here, and first I'm going to type in the 3.97. Woo! Be helpful if I type the right number in, huh? 3.97 minus 4, and it says negative 0.3 or 0.03, but because it wants the absolute value, I'm just going to write the positive value, and that's going to be divided by 4. So I'm going to say divided by 4, and so I know that my relative error is going to equal 0.0075. Now for machine B, I have my 4.12, which is my measured, minus my 4, which is my actual. So that's going to give me 0.12. I'm going to divide that by 4. This 4 is my actual. And here, my relative error equals 0.03. Now, because it says it allows the 0.025, I need to think, okay, which one of these is the one that is going to be the best? Well, it's whichever number is smaller. So my answer is going to be machine A, because the relative error is 0.0075, which is less than 0.025. Okay, so basically all I did is I drew my pictures, I labeled the sides, I knew my formula was the absolute value of the measured versus actual. Relative error will always be positive. I subtracted, did my division for each of these, and then I determine which was the correct response. So let's look at another relative error. This one is from the June 2014 test. Okay. This is a storage container in the form of a rectangular prism. So now I'm just going to draw my rectangular prism. It's not going to be beautiful. Okay. And it says is measured to be 12 by 8 by 4. Okay. This was the measured value. It says the actual measurements are 11.75 by 7.75 by 4. It wants us to find the relative error to the nearest thousandth. So first, let's just figure this out. So we've got 12 times 8 times 4. That's going to give us 384. This is our measured. Now we're going to do 11.75 times 7.75 times 4. This is going to give us our actual. And now we just use our formula from before. The absolute value of 384 measured minus the actual divided by the actual. So I'm going to type in 384 minus 364.25. It's going to equal 19.75, and it's already positive, so it's already the correct absolute value. I divide that by the actual. I get 0.05422. It wants it to the thousand. This is the tenths. This is the hundredth. This is the thousandth. I look at this next one, the 10,000th, because it's less than 5, or I'm sorry, 4 or less than 5. I know this stays the same. So this is my relative error. Let's look at one more. Janice measures the dimensions of the floor in her rectangular classroom for a rug. Her measurements are 10.5 times 12.25. This is the measured. It says the actual is 12.5 times 10.75. It wants the relative error to the nearest thousandth. Again, first we got to figure out what the area of each is. So we're just going to multiply. This is going to be 128, 625. And we're going to do our 10.75 times our 12.5. 134, 375. So now we have the absolute value divided by the actual. And I'm going to do my math. I get negative 5.75, but because it's an absolute value, I'm just going to write positive 5.75. Now I need to divide. I'm left with 0.4279. Okay, it asked, ooh, I forgot the 0. You didn't catch me. There we go. Because it asked for the thousands, here's tenths, hundredths, thousandths. I look at the 10,000ths. Because this number is bigger than 5, I'm going to round up. So my answer is 0.043. Alright, that concludes our video on the measurement questions pertaining to relative error.